Hello guys, today we are going to discuss mesh analysis. So according to mesh analysis, we assume that the current direction is in clockwise or anti-clockwise. So in this case we assume that the current direction is in clockwise. So according to that current, we put the polarity for resistor R1 and R3 according to that current. So in current branch analysis, the polarities of the resistor will be described according to the original current flow in a loop. So here in this case, if we apply Kirchhoff voltage law, according to Kirchhoff voltage law, the algebraic sum of all the voltage rises and all the voltage drop inside a closed loop is equal to 0. Let's apply Kirchhoff voltage law in a loop 1. So according to Kirchhoff voltage law, E1 with a positive sign and V1 with a minus sign and V3 with a minus sign. So putting all the values in this equation, so I1 2 ohm and I1 minus I2 with a 4 ohm resistor. As we know that the I1 current and I2 current are in opposite direction, so the current flow inside the branch with the resistance R1 will be I1 minus I2. Now let's simplify this circuit. Equation. 2I1 minus 4I1 plus 4I2 is equal to 0. So if we further simplify the equation, so it will look like is equal to minus 2. So we found the equation for loop 1, which is 6I1 4I2 and minus 2 is equal to minus 2. So if we divide the whole equation by 2, so our simplified equation will look like this. So equation for loop 1. So let apply the Kirchhoff voltage law in a loop 2. So here in a loop 2, minus E2 plus V2 minus V2 minus V3 is equal to 0. Putting all the values in equation, I2 with 1 ohm minus I2 minus I1 with a 4 ohm resistance. Let's simplify this equation. I2 4 ohm plus I2 I1. Now if we further simplify this equation, so it will look like it will look like 4I1 minus 5I2 is equal to 6. So if we put these two equations in a matrices form, so it will look like this. Now I1 I2 minus 3 2 4 minus 5. So Ax is equal to B. So if we apply Kramer rule in this equation, so I1 will equal to determinant of A matrices and for I1 we will put in column 1 matrices B. Now so the determinant of this is actually equal to 7 and the determinant of the numerator matrix is equal to -7. So I1 is actually equal to -1 ampere. So we found that I1 is equal to -1 ampere. Now for I2, determinant and we replace column 1 with the matrices B. So as we know that the determinant of this matrices is actually equal to 7 and the determinant of the numerator is actually equal to -14. So we found that I2 is actually equal to -2 ampere. So the current in across R3. So the current across 4 ohm resistance actually equal to I1 minus I2, which is equal to I1 is 1 ampere plus 2 ampere. 1 ampere plus, which is -1 and 2 ampere, so which is equal to 1 ampere. So the current across 4 ohm resistor is actually equal to 1 ampere. So this is the end of our lecture. Thank you for watching.